Welcome back, everyone. It is now my pleasure to introduce our first keynote speaker, Professor Amit Sheth from the University of South Carolina. Professor Amit Sheth is an educator, researcher, and entrepreneur. He is the NCR Chair and Professor of Computer Science and Engineering at the University of South Carolina. He currently leads the ambitious effort to establish the Indian AI Research Organization. Today, Professor Sheth will speak on neuro-symbolic approaches to robust and trustworthy AI with applications in health, pharma, and manufacturing. May I please request Professor Sheth to take the stage.
Thank you very much. Delighted to be among all of you. Well, okay. So I have dual affiliation right now. At least I'm in transition. For last 6 years, I established a university-wide AI research institute called AI Institute of South Carolina, and now I'm in transition in a way, and you all invited to look up IAIRO.ai, IAIRO.ai, and the name comes from take ISRO and replace S for space by AI, right? So it's very easy to remember. It's very ambitious effort, and I'll briefly introduce that to you, but let me give you this very quick background. So at IRO we do, not IRO, at AI Institute we do research in a number of core AI areas, but at the same time we also do extensive translational research. So you can see a whole bunch of areas of application or industry that we do work in, and the work we do is very so they are significant. Typically almost every project we have involve real partnership with the organizations that have the problem to be solved with AI, and we have access to their data, their expertise, their ability to participate in the evaluation, and our ability to deploy the results. So in that way we have been able to have exceptional impact. One of the most important things we have done there is to train world-class researchers and students and innovators. Just to give you a simple example about what I graduated 38 PhDs so far, 9 are on the way, and about 1/3 of recent PhDs had 1,000 citations or more before they graduate, and the average citations for these students that I have graduated is significantly more than 500. So making impactful work is been part of our DNA. And in short time, this is journey how we grew. This is a 3-year snapshot, 4-year snapshot, and so been able to scale organizations. Now I come to an event that occurred 2 years and 1 month, 1 week ago. So this was the day where I met PM Modi ji. I was invited to discuss one-on-one what is a unique proposition for AI in India, or what work we can do in AI where it stands out, where India can stand out in the world, and in the work, an application of that work to major areas. Now and then this is the first slide of the keynote I gave the same day at the 3rd Chief Secretary's conference. With that, now I get into the into what I discussed then and what we are doing now. So this is just to show on the left-hand side big challenges that generative AI, LLMs, still face. I asked it to describe 5 layers of AI that Jensen has talked about, Jensen Huang, and there are number of errors that were on that. right? So all the things that we talk about with LLMs face significant problems even today, and this was done only a couple of weeks ago. These are the 5 layers that Jensen Huang presented, the CEO of NVIDIA. Energy, chips, manufacturing, infrastructures, models, and applications. If you think about China has substantial advantage in energy. US is a little ahead or somewhat ahead in chips. US has the best infrastructure like GPUs and data centers on which they are hosted, followed by China. I'm going to talk a little bit about models and applications and where India can make big progress and also lead something at the world level. So if you look at AI today, you'll notice that in what you might call consumer market, US is by far the leader. Example of what makes US leader is ChatGPT and whole bunch of models along that line, OpenAI, Google, Microsoft, many other companies have leadership in this area. But China has already become a leader in enterprise market. So the models of the kind DeepSeek and the innovations that they have done, where they are typically open source or free models with open weights, and you can download that model on your enterprise. So for example, Airbnb is using Chinese models because they can host for themselves and manage it, and that has benefit of privacy and other issues, right, rather than uploading, and cost issues, cost advantage. So that's where, and China has the lead in the world. Jensen Huang noted that 9 out of top 10 institutions in the world in AI are in China. And I have reasons, this is all solid information, I would say. One of the, I think probably arguably the most important technology in AI has been the LLM. No doubt it is very useful, no doubt it is very influential, but it is jack of all and that master of none, and that observation gives an idea as to where India can be a leader. And I'm going to, there is one other very interesting thing that Gartner noted, that in 2 years, the majority of the AI task will be focused, majority of AI will be focused on solving the task, creating the task, and for specific reasons. Wherein now, the idea that you get is that if you solve very specific enterprise kind of problem and create the IP, India has a chance of making global products. It is too late. Now, certainly there is certain role for India to work on LLM, just like IIT Bombay is working on BharatGen, or AI for Bharat or Sarvam. They are solving a very, concrete problems that deal with, let's say, languages. India has a lot of languages and we need to support that. So in that, nobody else is going to do that, and hence we need to do that, and hence these efforts are needed. And so this is that's fine, and I'm glad that the government has provided the resources. But for the industry at large, they are not going to be necessarily making money, right? They are not going to build large commercial outcome that there will be valuable economy. So here is my observation. General purpose AI built for consumer market has limited value for enterprises. There is a need for a different AI, and that especially for high value and mission critical applications. And if India can take the lead there, we can participate in a major economic progress for us. and we can even lead in India. So for that, I have been arguing for a different kind of AI, and there we have 4 elements. Compact, these models need to be cheaper to make, small, and they should be you should be able to run them at various places on the cloud, on the edge devices, on the mobile phone. That this should be custom, meaning rather than solving a broad set of problems as let's say LLMs would do typically, they should solve very specific problem, let's say in finance, in healthcare, in pharma, in earth sciences. And when you do those custom models, you need specific data and knowledge to train them, to create them. India can have data because we have industry, we have people working on that. So we'll have our unique data, not the data that is on the crawl from the web, not the common crawl, right? But data that is specific to that industry or use case, and knowledge. People are working here. If they are building, you have healthcare data for Indian patient population, and you have knowledge because our protocols may be different than the protocols in the West. So you have that knowledge also. Then you need neuro-symbolic, and that's the thing I'm going to talk about. So let's see that in detail later on. And then composite, because when we create agentic AI systems, one of the agents may call a tool, another may call a large language model, third may call a small compact neuro-symbolic model, right? So with that in mind, we have developed 15 elements that are necessary, or at least some of them are necessary in solving some of the real world problems. So for example, you need safety, right? You need user level explainability. Suppose a doctor is going to use a chatbot, and if your system cannot explain how you came to that particular outcome, and the system cannot guarantee that you followed the specific medical guideline for diagnosis, for treatment, there is no reason why the doctor should use that kind of system. And your typical generative AI system cannot do that, right? Similarly, you look at several applications. The type of reasoning necessary for them can be far more richer than the kind of so-called reasoning models. The reasoning models are supporting a very specialized kind of weak reasoning model, a pattern-based reasoning, right? So what you need is quite different than the typical black box generative AI technology would support, right? That way you need grounding, you need alignment. Alignment would be that anything you want to do on a large scale in a society, you have rules, you have regulations, you have policies, you have guidelines, you have laws, right? Human societies work well by having all of those, right? We can't be, in our interaction with others or with the nature, we should not be, we should be bounded by certain things, right? Current generative AI technology cannot be made to, work within those bounds of those policies, guidelines, protocols, right? So you need that kind of thing. So there are 14 of those here. These are some of my this year's dissertations that came out, and they address many of these things, as you can see, right, in the red. That is, I think very powerful and very practical and very important. And again, what I want to convey with you is that we ought to be working on technology that is practically very, very important. We can clearly see the market for them, and that we can own, we can get the world leadership in those areas. So, now briefly give you a sense of neuro-symbolic AI. Just ask yourself, what goes into understanding me? You're listening to me right now, right? What goes into that? You have lexical knowledge, you know where the comma is, where I'm stopping, and the grammar, and you know how to parse. You have linguistic knowledge, what is same as, what is a synonym. You have common sense knowledge. You have specific knowledge of the real world, that this city is the capital of this state, and you have very specific domain knowledge. You may all be specializing in different domains, different areas. You may be working in material science, you may be working in physical, in physics or astronomy. You have that knowledge. Because of all of these together, you and I can communicate very effectively. Ask yourself, which AI technology does that? They don't. The large language models have diffuse domain knowledge. They come across a lot of medical papers, but that is not concrete enough to explicitly state the particular medical protocol or guideline that must be followed in a particular situation. It does not have the knowledge of what drugs or pharma products that a patient is consuming, and that you should not be given anything with the side effect. It does not have that. It's not that personalized for you, right? So this is the essence of neurosymbolic, in the sense that there is certainly a lot of power of data, and neural network technology has tapped into that very, very well. Large data, getting the patterns out of it. So you're taking massive amount of data, you are creating vectors out of that, embeddings, you're creating this parametric space, and you're hitting your query, converted into vector on that parameter space, and you are now, this is all probabilistic knowledge. They are not precise, they are not so they cannot give. This is why the hallucination happens, right? The knowledge is the one that bounds it, makes it to something that society, medical rules, everything has to follow, right? So there is also another very influential work, Daniel Kahneman, who got Nobel Prize in economics. He talked about thinking fast and thinking slow, and I had independently talked about semantic, cognitive, perceptual computing. So thinking fast is perceptual in my view, thinking slow is cognitive in approach. So system 1 and system 2, our brain can do both of them very well, and these two aspects interleave and work together in very mysterious way. A good system, brain inspired system of future will need to support both of them very, very well, and that is what neurosymbolic is about. This is neurocentric and that is symbolic centric, right? So the idea is neurosymbolic. You want to connect. On the left hand side you see neural implicit parametric representation. On the right hand side you see symbolic explicit knowledge representation, and the idea is to bring them together. So on the left hand side you see neural network and deep learning. On the right hand side you see knowledge graph, label nodes and edges. So all these things, like I will be able to represent the policy, guideline, governance, all of those in the symbolic form, and I need to figure out a way that one influences the other. For example, I need to figure out a way for the symbolic part to constrain the behavior of neural part, so that you are following those rules and guidelines and so on and so forth, that not totally unconstrained. So the next part I'm going to go through very fast. How do you connect these two technologies and two different approaches, right? So at a very high level, a generic architecture would be that you have data of all different kinds. You have what we call feature abstraction layer, and a neural reasoning layer, and then you have knowledge processing here. So that you see the neural part on the top and the symbolic part here together, and then you have to come a way to combine them. Before the transformer, the historic 2017 work, we had already been working on this area, and here very simplistically put, this is a paper that with the example of mental health. What you see here is that we create here, this is simplistic approach. I have defined this neuro-symbolic into shallow, semi-deep and deep infusion. The knowledge is infused into the neural network technology in different ways. This is a shallow infusion example where the symbolic part is converted into again the matrix of vector space, and then the two are combined. Right? Now, this is not the best possible way, but this is the easiest possible way. It's not the best possible way. That is that the same problem I said about taking data and convert that into parametric space or embeddings is a lossy one. Here, taking a knowledge and converting that into neural representation is a lossy one, but it does improve upon the results. Post transformer, there have been several ways that people have tried to improve the neural processing by using knowledge, and at a very high level the idea is to improve the attention. So, suppose you have two phrases, World War I and World War II, numerals 1 and 2. Textually they are very similar. Only difference is one character, 1 and 2, but meaning wise they are far apart, right? When you use purely data driven technique, you have difficulty in understanding that these two are very different, semantically very different. With the use of symbolic representation and semantics, you are able to bias the system such that it understands the distinction between these two separate events, and that is how you can build that. So, I won't go into a lot of details. If this was AI class, I would. And then it shows this is one of the technologies and algorithms we had developed, and on the right bottom you will see that we were able to make that distinction very well, again through a neuro-symbolic approach. And this thing on the top basically shows how the knowledge part was able to modify the attention in the neural network algorithm. Now, in this particular case, the idea here is that we would so there is another approach. The first set of approach I discussed is to take symbolic part and improve upon the neural part, right? The other approach is that take the neural part and do lifting. Lifting meaning taking out from the neural part, which is messy, massive parametric space, into some graphical representation. Now you have teased out the representation that is comparable and easily connectable to the knowledge representation. So reverse, right? Rather than getting the knowledge into neural, lift out knowledge from neural and connect with the knowledge part. So that is the another sort of general idea that we do. And in one of our papers we discussed see lowering part on the left hand side, lifting part, symbolic to neural, neural to symbolic, right? And there have been multiple, there are two, along with that there are generally two broad strategies about knowledge. One is logical representation and the other is representation knowledge graph. My team has been a long time proponent and leader of the one that uses knowledge, and there are others who have used logic. My simple view for this audience is that the one that uses logic doesn't scale, and that there are very few people who have expertise in modeling a large amount of knowledge in logical terms, right? In think about Prolog, think about other rule representation languages. But we have scalable practical approaches to create very large knowledge graph. For example, we work with pharma industry, and I think have created world's largest pharma knowledge graph with millions of entities and tens of millions of facts, right? So, and this was created by a tool that we have developed for creating knowledge graph and managing knowledge graphs, and we could take unstructured, semi-structured and structured sources from which we will extract out graphical information that and connect all together and basically create a knowledge graph. And so symbolic lifting versus lowering, knowledge graph versus logic, and that is how the variety of approaches can be developed and have been developed. In this one slide, I show that there have been number of studies that have shown that generative AI solutions have done poorly, and that with Neuro-symbolic approach the results have significantly improved. And you can see medical diagnosis, insurance context, anomaly detection on manufacturing, autonomous agents driving, all of these contexts, these things have been developed. Here I want to make a very interesting observation. In 2017, I was invited to give a keynote in Chengdu, China, and there were 600 people in audience, and I was introduced by a guy who was working for Google Knowledge Graph. You might remember that in 2012 and 13, Google came up with Knowledge Graph, and they changed their machine learning based search algorithm to semantic search, right? Now a moment of big pride for me is that I had done that work in year 2000 and had filed a patent award in 2001, and I had paying customer for my second company that did just that. But I don't run Google right now. One of the biggest problem was that in that year NASDAQ crashed, went down. So for 4 years in a row, VCs they had decided that you cannot make money in search by advertisement. So they did not fund me and my company. And in 2004, Google went public with the business model of advertisement, the same that I was trying to use 4 years earlier, but I think we are at the wrong time, right? So anyway, but it showed the power of knowledge graph. Coming back to the story, in Chengdu, 600 people were there. They understood the power of knowledge graph, which America did not, which US did not. US always wanted to do massive brute force, high, massive amount of data, massive amount of computation, and create, billion parameter, trillion parameter, and spending $1 billion to train model. That is what they did. There was some success, and there have been some success, but you'll see that practically all AI companies are actually making loss, right? OpenAI making massive loss, and it does not have business model to succeed. We will not go into the business part. Happy to discuss later on. Now we have built multiple applications. I guess I don't have the way to start these videos right now here, so I won't. But all these slides are on. If you go to LinkedIn, I have posted this slide, and you can play all of this video. So I'll just read the title: Allure multimodal guided environment for helping children learn to solve Rubik's Cube, alleviate mental health chatbot, and generative AI and external knowledge based retrieval for library science and deep research in library. Now I'm going to give you some snapshot of the kind of things that neuro-symbolic approaches do that generative AI cannot. So in this virtual health thing, you see there a text, you see here the knowledge graph, and you see there a definition of what is the definition of OCD, right? Now imagine trying to classify that text into to decide whether it is OCD or not. You can do to using neural network or deep learning, you can do to some level, and it may be useful in some case, or not useful in enough case because the quality would not be that high, but it cannot explain that the system, AI system, has followed all the aspects of that definition to come up with the decision or to explain the decision. Here, by use of knowledge, you are going to do that, right? I can see whether all aspects that obsessive, is obsessive, intrusive thoughts, ideas, or sensations that matter. All these aspects can be validated here through the use of knowledge. And so there is a video that shows this is just a chatbot going on, and the graph is built continuously, and doctor can see whether it has done the right reasoning to come to the conclusion. This is a personalized version. I'll bypass. Here's another very important example. This is a conversion that is happening in a mental health chatbot using the state-of-the-art technology when this slide was made, and the chatbot asks the question: for a MDD case, major depressive disorder, one should not be asking the patient that question in red. That is a thing which is a characteristic of suicide or suicidal behavior. That will hurt the patient. So, and it is very hard for generative AI to not do that. And hence, here the neuro-symbolic approach, you can see that sentence being rephrased in such a way that in that particular condition, medical condition of the patient, you could not ask that question and make it a safe chatbot. You even until last year, in 2015, there are multiple major stories where due to the character AI is one example, OpenAI is one other example, where teens have committed suicide by using because of their interaction with their large language model. So they have not come up with a solution for that, and the same thing is happening with Grok or nudity aspect of it. So this is a very important thing. This shows in one of our applications, which is in nutrition, the variety of reasonings that you need. Does anybody know how many of these generative AI based LLM can do? Very limited part of this, right? So the generative AI or LLMs are highly inadequate to solve this kind of problem that require use of symbolic representation. And now I probably won't be able to go into this detail, but the architecture, meaning building scalable system, your LLMs, your agents, your hybrid architecture, and we have C3N. C3N is compact, custom, compact, neuro-symbolic agentic AI system, composite AI system, which is what we have built and are building. So you see earlier I showed that those 5 categories, levels that Jensen talked about. The way we want to be a leader in India is that IRO is building a platform that goes on the top of infrastructure. So India AI has infrastructure, right? All this GPU 13,000. We are building a platform that just goes over that can scalably, frugally train the C3N models, many. So above infrastructure is a model. I am not interested in this trillion parameter model that costs $1 billion. I am interested in models for financial services, models for know your customer, models for mental health, models for diabetes, models for manufacturing automation. They just do that very well at much lower cost with high IP, so that Indian startups and Indian corporates can build high value global products. The number of people, influential people, IRO's board includes Sarar Sharma, iSpirit, first CEO of Yahoo, and Ajay Chaudhary, who has written about Aspire and both have talked about India not, should be a product nation. That is not. We have been great in IT services. That's not going to, that's skill oriented. We need deep talent that is necessary to create products. And so that's what IRO is working on, is started to work on. So we have built some example applications again, and these are, again, I very much invite you to look at the videos as an example. And there is a healthcare for behavioral health, nutrition, and smart pilot for highly automated factory like Mahindra's highly automated EV factory as an example, or a semiconductor foundry in Gujarat that is coming up. That's where those kind of technology will be useful. Okay, I'll bypass some of these other things, and then I have details thing on smart manufacturing. So thing to understand is, look at this slide. It is pretty significant. What do you see here? Alignment, grounding, reliability, consistency, planning, abstraction, interpretability, explainability, attribution, causality, instructability, reasoning, safety. We have in this one application, we have detailed specific example for the need for each of these, right? And I hopefully also try to say that, convince you that current generative AI technology and consumer grade models, or even Chinese enterprise, they are going to enterprise market. They are still not perfected enterprise model that I am talking about here, right? So we want to create those enterprise model. We are creating those enterprise model. We have prototypes of this already, but we'll be perfecting that more, and as early win for IRO. And so this is a actual factory is set up, and there are sensors, there are cameras and all that. In real time, all that data is collected. A module is on edge device sitting on the factory floor, telling you about, it's predicting a failure. It is giving you root cause analysis, causality. It is providing forecast. Not shown here is it is doing replanning when there is a failure. Excuse me. And there's a bit of technical stuff here on variety of problems being solved in replanning here. RL, reinforcement learning based work, and this is similarly Nourish has all these again things. You can see different color. Thank you very much. And so Nourish does many interesting things. But you see, it uses all these, specific knowledge. That is what makes Nourish far better than what you can get from a generative AI solution. It can give you cooking method, changing cooking method, like, instead of frying, do the baking or whatever. Of course, understands multimodal. But for that particular patient who has diabetes, it can help you make right choices on a continuous basis, right? So here, again, there is a recommendation is giving knowledge graph, explainable and traceable results. So he says pork and grill, it creates carcinogens, avoid. And so many other things. And it also shows the tells you about the source of knowledge that was applied in this situation. So now towards the end, the IRO that we are building, Indian AI Research Organization, and has several interesting things. First of all, it has a partnership of totally world-class people at one place. So if I were to put it one way, it has people like Ramesh Jain, go and meet him, He is the father of multimedia and runs Institute for Future Health at UCI. Similarly, it has some of the top-notch researchers that have trained a lot of highly successful PhD students. Every year in the last 3 or 4 years, my team has published 40 to 60 publications. So some of them have won awards. But what is important is that half of them have, on the average, 2.5 students. Typical papers these days have 6-7 authors. So 2.5 of those students, co-authors, have been from India. Students, undergraduate students at IITs, BITS Pilani, IIITs, and other places, they are part of, they are interns with my team. So we have been able to train the talent that we have here at a world class, and then they done PhD with me, or they have gone to MIT and done pursuing PhD. All of these have happened. Now, world is changing. In last year, world has changed drastically, right? I don't see why an IITian should graduate from here and go to US. And feel free to talk to me, but there is no reason for that. We want to train that talent here. Arvind Srinivas, or I, or Ramesh, or Pramod, we all studied here, undergrad for sure. Ramesh, of course, studied all the things here, but he's a rare exception. But the rest of us went to US, did our PhD, we work for companies. Then we did companies. I done 4 companies. Arvind Srinivasan has done Perplexity. But they did not build those companies here. We want to train, make that, people, train those innovators here and build the products here. So we are building this kind of technology that I already described, that is unique, and so foundational AI. And then we have taken several, areas, 3-4 major areas: health, pharma. Indian Pharma Association is partner and part funder of IRO. And other interesting thing is that we also, not beyond researchers, we have also, some of us have built companies, but we are not, I worked in industry 30 years ago. We are industry experts like Apple, Google, IBM Research, DeepMind, Amazon, LNAI. They are working with us, and they will be engaged with the researchers in training that talent at IRO. We are not going to give degree, so students can continue to do their degree at IIT or BITS or wherever they want, but we will give that internship very deep, and they will work with us 1, 2, 3 years, and the outcome will be comparable to the best anywhere in the world. We of course have very big competition, particularly China, but okay. Well, that is enough of an introduction,